Easy case, so that you don't have to do any configuration. And the way this plays out in Rails is that in general, you don't have to write very much code to get the simple levels of functionality you're looking for. The typical quick web application that might do CRUD operations takes almost no code at all. The other ones would be like, don't repeat yourself is a big one that they constantly tout. I know that I have to repeat myself again and again and again in Java. It's very difficult to avoid it.
I think an API called FIGS, programmers, well, you figured it out. And that didn't go anywhere though. So I hope we'll do better this time. My name's Tom Gaskins. I work for NASA and I lead the Whirl Wind development team, a team which right now consists of 4 people, 4 engineers, half-time system administrator, and we have someone who tries to manage us as well, a job I wouldn't want to have. I want to show you a couple things really quickly. Well, I'll get to the agenda in a minute, so you people who want to figure out whether you want to leave or not will have a chance. So if you could switch to the screen, please, to my machine. Anybody know what that is? That's a naked Earth. That's the Earth without water or clouds. It's kind of amazing, isn't it?
Wow.
Okay, you can go back to the slide. Where's my cursor? Okay, so here's what we're going to try to do today. We're going to first I'm going to give you a little bit of history of Whirl Wind. That's not on here. Then we're going to build an application. We're not really trying to build one, I found out. So we're just going to walk through and I'll show you how it works, how you can create a Whirl Wind application very easily. I'm going to show you what you can do to deploy it with Java Web Start. If we have time at the end, we'll actually do the deployment. This is a Whirl Wind presentation, not Web Start, but it's interesting. I wanted to show it, but I may not have time. And then we're going to look at an applet. So Whirl Wind could be an application, no, Whirl Wind could be a component in an application, or it can be an applet. And we're going to explore both of those. After that, I'm going to describe a bit about the architecture and the API, and then tell you where you can get stuff. About 10 minutes before the Q&A session, Darren Humphrey is going to come up and give us a demo of his X16 application, simulation application. Did everybody see that, the keynote? No, did anybody see that? Okay. That's pretty cool. So Darren, that's a good example of what you can do with Whirl Wind. And if you notice in that thing, you're looking at the application, you're not looking at Whirl Wind. Because Whirl Wind's job is as a component, it's not an application. So a brief history of Whirl Wind. It started out as kind of a skunkworks project in a NASA education office as educational software. We did it because we could. The technology, the hardware could now do it. Thanks to video games, the computer, the graphics hardware of machines was certainly adequate to 3D graphics, and the network was so fast you could print stuff down on demand. We quickly went open source. It was NASA's first open source project. Then Whirl Wind developed into an application in its own. It started out as a component, a .NET component. It developed into an application of its own that does still pretty much what you see, Visual Earth, Google Earth, all this whole genre of 3D globe visualization things. They're becoming ubiquitous, and they should, because it's great technology, and the technology and the supporting technology is there. Anyway, but we saw that application, and people, came to us and said, we want to do this, and we want to do that. And you have a plugin architecture, but there's only so far we can go with that. And that's exactly the case. There's 2 models. You can have a browser that you put stuff in, or you can have an application that you put stuff in. Well, we wanted to flip the model around and we're going to take Whirl Wind from an application that you plug stuff in to a plugin itself to other applications. And that's where we took it. And at the same time, we wanted to go cross-platform. We started out with .NET because at the time I wanted to learn C#. We tell Microsoft this because it's such a great platform and everything, but I actually live 2 miles from Microsoft. I wanted to bring my daughter's Mac, that'll tell you what I feel about the products, but unfortunately my property values are directly related to their success. So. I have to be careful always. Plus, frankly, Microsoft has been very helpful to us. In fact, some of the imagery that we load, that you get when you run Whirlwind, it comes directly from Microsoft's Visual Image servers. They've collaborated very heavily with us. They give us a lot of equipment, just like Sun has. So anyway, that's more long-winded than I wanted to be. So what I said is Whirlwind is this is Whirlwind Java, is a component for building applications. What kind of applications? I already talked about that. Well, not just applications, but applets. Applets that really take people somewhere. I think we're all used to, in a web browser, static, flat images. You might be able to slide them around and stuff, and that's all fun, cool and useful and stuff. But I liken what you can do now to the portraits in the Harry Potter books. You walk up the Hogwarts stairwells, and you have all these, people looking at you in the picture. The pictures actually move, they talk to you, they feed back. You actually have another dimension, which just takes your mind leaps and bounds farther than it did without it. So we wanted to make sure we could do applets, and we wanted to make sure we could do this class of very highly customized applications. So here are two examples. The one in the upper left is a time series data animator and editor. So the Whirlwind window would be that where the globe is, obviously, and off to the left you have dialog boxes that help you move through it, download new images, edit images, and so forth. So that's a very highly customized application. You're not going to do it in a browser. Down at the bottom is another very highly customized application. The people who created this, we did not create these, by the way. These are other people who did these with our technology. The people who created this application have very specialized needs relative to security, to how performance, the whole infrastructure behind it that it deals with. And they really have to be tightly in control of every aspect of that application. So they came to us, and we've been helping them, and they've been helping us quite a bit. And then there are, of course, the nefarious applications that keep track of us, right, and continue to erode our privacy. Sometimes I feel like a lawyer with some of the stuff I have to build. You have to do things you don't really want to do. But, I'm not saying I don't want to do this, but some of these uses, my first job I had an application, and it's going to be a little bit better. Okay, now you can go back. I appreciate your patience. There you go. Code. Imagine that. Okay, so this is the hello world of Whirlwind. Man, what is it with these mics? Okay, I'll struggle through. So this is a Java swing application. So as you can see, it starts off with creating a JFrame. It imports, well, of course, it imports two things from Whirlwind. Whirlwind has about 5 packages. The main package, and then packages that are specific to the toolkit that it's running in. In this case, AWT. There are not yet, but there will be packages for SWT and most of the standard toolkits out there. I hear applause. By the way, if you have questions, go ahead and stick your hand up. I'll try to answer real quick. Just a few now. We'll have a Q&A session later. Anyway, so we create a frame. The simple thing you do to create a Whirlwind component, it's just like a panel, a button, whatever, is create a Whirlwind window canvas. And that takes care of just about everything you need to do except defining a model. Now, a model consists of a globe and the layers you want to see on that globe. The layer is just a layer of imagery or data or something like that. We'll see those in a minute. Anyway, so you create your canvas, you set a size, you set a model, and you just create a standard basic model, and you run it. We're running on IntelliJ here. We were very nice in the early days, and they gave us free licenses. I tried using NetBeans recently, great product. I mean, I didn't like it when it first came out, but it's pretty good now. But once you get used to something. And this is a Windows machine, so you can go get coffee, I guess. Does anybody know what this thing's doing when it's doing it? I wanted to bring my daughter's Mac, like I said. Anyway. Wow, this is really slow. Okay. Anyway, so with those 2 lines of Whirlwind code, we end up with a full, 3D world. Oops. Actually. That's the wrong one. I love tolerant audiences. Okay. This is the hell of the world. Hopefully we won't have to wait 5 minutes again. Okay, there we go. Okay. So that's the simplest Whirlwind program you could make. Zoom in. I like to go to my favorite spots here. Anyway, it's a slow mouse. Tilt down.
Yes!
It's funny. Whenever you do this, when I do that, it's just amazing. I was looking for something. I was trying to find somebody's house, right? And I said, well, let me look sideways. I went like this, and the whole room. Day by day. Anyway, so that's Hello Whirlwind. It's our new compass. Okay, now let's go to another one. So let's go to another one. Okay, so I'll show you how we do what happened here in a minute. So now we've created an application that has a little status bar on the bottom there. So it's telling us where we are. We go to Rainier now, we can see how tall it is. Get close enough to see. Okay, so it's some 4,004 kilometers high. And go do the standard thing. I live over here someplace. Modest dwelling that someone like me could afford on a NASA paid salary. Actually, no, I'm actually not a NASA employee. Just a contractor. You make more money that way. Anyway, I live there. So, and if I want to look at, so I've turned, so over to the left here are just a sampling of the image sets we have available by default. So there's the standard blue marble stuff that NASA puts out, some stuff from USGS. That one there, as you can see, is the very high resolution. I think it's 1 meter resolution or sub-meter resolution. Of course, place names, all this stuff as we're doing this. Some of this data is cached, but when you see down on the right-hand corner that little downloading symbol, that means that the data is actually being downloaded from NASA's server. Or in this case, since we're looking at the urban ortho data, this is on Microsoft's Terra server. So anyway, turn the comments back on. So let's look at the program that did that, which I was supposed to do first. So. Okay, so with some simple additions, right? So here's our program again. What I added here were these lines, just add some layers, okay? Now layers are pretty obvious. Right now they're classes. So you instantiate just this little array of classes. Blue marble stuff, Landsat from iCubed. iCubed is a company who, well, I'll talk about that later. They donated all that imagery, beautiful imagery to us. Anyway, those are the layers. This code all looks the same other than it adds another panel on the left. The status bar is a Whirlwind thing. So it's a component, it's another component, not just a world window, but it's something that works in tandem with the world window that knows how to listen to Whirlwind events and does the update of that long elevation and stuff. So these are the types of things we're doing in addition to the core Whirlwind component. It's components that work with Whirlwind. And then this other thing, a layer panel, which is the thing you saw on the left there. Again, another component that we built with Whirl Wind. So that's pretty much all you have to do. You'll see if you look at the documentation, when there is documentation, that you can do a lot more things. You can put in all kinds of stuff, make layers. Any questions on programming? Okay, so deploying these things with JavaWeb Start, I'm not going to do it, I'm just going to show you. We've provided some support for doing that, thanks to being pushed really hard by some. It's a cool technology. Okay, so I'm not going to bore you with all this, but anyway, this is essentially a template. I mean, this is what you need to deploy an application with JavaWeb Start that uses Whirl Wind. And the things I want to point out to you is that Whirl Wind uses JOGL, which is the Java OpenGL binding. And with a simple line in your JavaWeb Start JNLP file, you can suck those down. It just happens automatically. That's all you have to do. For Whirl Wind, you can do the same thing. We've installed libraries on NASA servers that you can just reference within your JNLP file, and then all you have to worry about is your application. Not trying to get Whirl Wind, conversions and stuff like that. Anyway, so that help is there for you if you care to. Okay, so we can go back to the slides now, please. Okay, so just as a review, you saw the first part there where we made the canvas. What I didn't show you was the second part because that was handled by the status part. Whirl Wind has, just since it's an AWT component, it has event listeners. It has 3 classes of event listeners. I'll show you in the next slide. In this case, on this slide, it's installing a listener for the selected listener. Now, the selected listener gets called when something in the scene gets picked. There might be an icon there, or terrain even, or any object in the scene gets picked. The selected icon, the selected listener gets called. I'll come back to this slide when I talk about the architecture a bit. But if you look down in the bottom left there, these are the 3 classes of listeners we have, right? So you can listen to position changes being long elevation, select I talked about, and rendering listener. So since Whirl Wind is a component that plays well in applications, those applications are typically 3D graphics applications, and we're providing the context. So we have to cooperate with the application's use of the canvas, essentially, of OpenGL. That's pretty tricky, so we've done a couple things to try to make that easy, to certainly make it possible. So this rendering listener is just one aspect of that. I'll come back to these others. Okay, so let's look at an applet. So if I were going to build an applet today, I'd build this one. Anyway, this is what we saw. So this is, this is live. We saw a picture of this before. It's what are we in? We in Safari there? Okay, yeah, Safari browser. And all these things are live, right? So here's the applet code, or the HTML code. So yeah, if you're not asleep yet, this will help. The things to point out, I put a highlight in red, what matters here. So the rest is pretty much boilerplate. So your applet code, you're using a JOGL applet launcher. Okay, that's the component provided by JOGL to run a 3D application, OpenGL application within a browser. A very nice tool. By the way, if you haven't tried JOGL yet, you're in the 3D. I really urge you to. It's probably I don't know why it took so long, frankly, but I'm glad what came out when it did, because it is truly not. It's really nice. If you're an OpenGL programmer, you recognize it immediately. You've got some really nice utility classes. Really good job done there. Anyway, so it references the JOGL libraries and on like that. So all this will be is in documentation stuff. So. Okay, so let's talk about the architecture. Is this counting down? So this is the overall architecture of how Whirl Wind fits into an application. Whirl Wind is a small number of replaceable components. So, does this work? Okay, so all these little blue boxes, even the application, It's a replaceable component. Okay, so here's your application. The application interface is at the highest level with something called a world window. That's this. That's what you actually create. We saw an instance of that. That has an interface on, a very small interface. That, you know, it's got doors to bigger interfaces and other classes, other objects, but it's kept intentionally small. So world window is what you create. The application creates it. A scene controller is responsible for keeping the scene updated. Timing, working with the window system to get events through the notifier, through an input handler, to map essentially user actions to, you know, to semantic actions, zoom, pan, you know, tilt, those kinds of things. So that's the scene controller's job. The view is what controls what the user sees, how they see it. The frame controller is responsible for the content of each frame. The scene controller controls the frame timing. The frame controller actually controls what gets drawn and how the collaboration gets done with the application. This is the point. This is where the application will get involved in replacement almost immediately if it's got some serious OpenGL needs. It'll replace the frame controller, which is designed to be replaced. So it's got a small interface. We've kept it, the whole thing, the code as small as possible and its function as small as possible, so it can't. So the application, this is where the application will coordinate buffer flips, Z-buffer clearing, things like that in the frame controller. Let's see, the model, as I mentioned earlier, encompasses the globe and all the layers you want to put on it. So when we saw the globe, that imagery there, that's all a layer. As more imagery came in, there are separate layers. We just call them layers. That's the vernacular. The application typically interacts with a model. If it goes less than the world wind, it actually interacts with the model to create a globe. A globe need not be Earth. It need not be a WGS84 Earth. You know, it could be a spherical Earth. It could be Mars. It could be any planet. It could be a moon, a Death Star. It's done, right? In fact, Sloan Digital Sky Survey, it's the universe, where they've captured every beautiful image that has ever been made about, you know, space and put it in this database that you can zoom into. Wish I could show it to you. Anyway, a globe can have a bunch of layers associated with it. It's completely arbitrary. And the globe has something called a tessellator. Now, everything in 3D graphics gets drawn as triangles. At the bottom, at the end of the day, everything's a triangle. That's what gets sent to the graphics card. So you got to chop up these things, you know, these round things, into triangles. People have all kinds of ways they want to do this, and you want to do it differently. So when it's mountainous, you want to do it really fine. When it's flat, you really don't want to do it real fine, because you want to get all the performance you can. Fewer triangles, typically, the faster you run. The tessellator, like the view, unlike the frame controller, are three things that are going to be heavily replaced, because people have ways to do that that are special purpose to their application. For instance, you can tessellate a planet, well, our planet, I guess, based on population. You know, population centers, you can make a real dance about them. So again, I'm trying to get the flavor across to you that we've really tried to design into this thing replaceability, not extensibility. I mean, it's all extensible, right? But in my history in computer graphics, the model is either you do it all yourself or we do it all for you, and you can't do anything. It's just a broken model. Which is why today you see, you know, the two most common graphics APIs used are DirectX and OpenGL. There have been, you know, a plethora of so-called scene graph APIs out there that tend, you know, say, give us your data and we'll take care of it all. It just doesn't work because there are too many special purpose needs. So this is our attempt to kind of break through that limitation, that historic limitation. At the client. In fact, we're just looking at a little component at the client. Behind that is this enormous infrastructure of servers, networks. NASA has, I couldn't even count the data NASA has, and we certainly can't look at it all. And it keeps streaming in all the time, and not just NASA data keeps streaming in. We get all kinds of people have stuff out there, sensors, satellites, and whatnot. So there's a whole notion of these data farms. And none of this would work. You know, World wouldn't work, Virtual Earth wouldn't work, Google Earth wouldn't work without these huge infrastructures behind them. And we don't really see them. We kind of take them for granted. But believe me, they're there. They take a lot of work, a lot of thought, a lot of maintenance. especially when you release something and suddenly the world hits you, you know. The universities, they have a lot of research centers. They have their own stuff they want to look at.
3D
ours is fine to look at in context.
real-life 3D
You have to provide the context.
object generated from a 3D printer.
When we do use, we try to use standards for...
Go ahead and switch over to the other screen, please. We've had the opportunity to work with NASA and with Sun to build a really cool collaboration demo that shows off our technology, which is a tool for building interactive 2D and 3D components using Java. And we were able to take that and in a matter of 3 weeks with a new hire engineer who was new to our company and didn't even know our product or Whirl Wind, we built this demo. Ken Russell called us up about a month and a half before GDC, Game Developers Conference, and we talked about this, and 3 weeks later we had this demo, and we're able to show it there. Now, what I've got here is an F-16 aircraft model that was created in 3D Studio Max, and I've brought that in to the tool and hooked it up to a flight simulator model that Ken had previously ported from Fortran.
He doesn't look old enough.
And just to show you a little more detail, I'm going to go ahead and zoom into the cockpit. And we have a cockpit that we also built using our GL Studio tool. Go for a little spin around here. Come down and see some San Francisco data.
So what you're seeing is the scenery and the scenery is whirlwind, but the viewing and the object there is GL Studio, is the application.
Right.
So this is a good example of what we've been trying to do, is just be there and not get in the way.
So a couple things to let you know. One is, if you want to take this demo and you want to go try it at home, if you go to simulation.com/JAVAWone, that's spelled out JAVAONE, there's a link right here. You can go ahead and download this. It's a Java Web Start, one click. It runs on Windows, Linux, the Mac, Solaris, x86. I've tried it everywhere, haven't had any problems with it. And also, if you want to come and talk to us a little more, we're in booth 1302 on the exhibition floor.
Thanks, Darryl. So, any more questions? Yes.
First of all, thank you for presenting this. This is important technology, and the fact that it's free and that it's Java and that it does great 3D visuals.
So here we are. Okay. Let's take a tour of the exhibition pavilion. Follow me. So this is Motorola.
Be sure to stand in line right now.
And this is where you can win a
We'll be
competition.
temporarily taking a break and closing down the line.
So this is the Java Blu-ray showcase over here, and you can see all these machines, Blu-ray machines that run Java. That is Spider-Man 3. I think this is I don't know what movie that is, but it's looking very cool. All these boxes run Java. And this is a disk T. Here's another competition going on for Crest software. And it's rows deep here, so let's move swiftly through this part. This is Talon. Excuse me. Walking through Talon, back through the application showcase. Let's move quickly along. Here's British Telecommunications, otherwise known as BT. Look, they're doing company from Blighty. Doing an SDK, software development kit. What are you doing?
Oh, we're making phones ring around the world, anywhere in the world. If you want to talk to Pavel here, I'm helping this guy.
Yeah. All right, yeah.
We'll tell you.
All right, yeah. No, good.
Come on over here.
All right.
All right. Yeah. So we're British Telecom. We're a phone company, right?
Yeah.
Pretty obvious.
Yeah.
what we want to do is make it really simple for anybody who does Java application development to be able to do things like make voice calls in one line of code, or do conference calling, or send text messages, or do location. So we want to, it doesn't matter what the next great app is that you build, if you have those kind of needs, it makes it really simple. So in like one line of code, you can basically just say, hey, I got a third-party call. I want to start the call. I'm going to originate from that phone number. I want to call that phone number. One line of code. Those two phone numbers can be anywhere in the world. Doesn't matter whose network they are. Doesn't matter.
So that could be VOP, internet?
Anything. Doesn't matter. As long as there are two phones that you can connect to.
That's amazing.
That will work. And then the same thing like with messaging. Basically, okay, I create a new message. I say send to that phone number. It could be multiple phone numbers. That's the subject. That's my message. One line of code. It will send that message out to any phone that can take an SMS or a text message.
Amazing.
Yeah, that's it. Totally cool.
Look at that. In Java, you can phone someone and you can say and do a text. Fantastic. Thank you. Brilliant. Thank you. So that was BT and W21 SDK or whatever it was called. So that was BT and the W21 SDK. So that was BT and the W21 SDK allows you to call from one line, call one phone number to another phone number for any place in the world with one line of code. So this is a special .org area for small companies. And what are they viewing here?
So what we do here is you have a stereoscopic 3D visor. You've heard of Project Darkstar, which is this mass multiplayer server running on Java. Then you have the client, where we have this Wonderland MPK20. So this is an area where you can walk around, you can network with your friends, you can chat with people, you can bring up your applications in 3D space. What we're doing is we're enabling that to be true stereoscopic 3D. So you put on TD Vision's 3D visor, the TD visor, and you feel like you're there. That's what we're enabling for you guys.
Excellent.
Yes.
Sounds like the lawnmower man come true.
That's right. It's the Lawnmower Man 2007.
Oh my goodness, I'll be sucked in the machine.
You got it.
Okay.
You want to take a look?
Yeah, I'm going to
try
take a look. Well, that was Project Darkstar, a truly outstanding piece of development. Really brilliant 3D development. It's coming. And now we have a Robo Sapien that's trying to get out. Oh. Is he responding to sound?
Don't get tangled up, buddy.
Step away from the vehicle.
Turn around. He's tracking.
He's tracking me. Yeah. You're safe.
Robot is
Right turn, left.
But I'd say that after I recovered from my cookie, the cheeseburger, I swore I was going to order it.
Go away, okay. Say something, no? That's quite cute, it really is. Alright, Robo, we'll leave you for now. That looks over there quite interesting. There's lots of interesting embedded Java work going around here in robotics and stuff. This is Project Darkstar again, the environment. And this is a competition or a game. I think you have to program it. You program a scale electric car, I think, to go around the track. Oh, and you can change coefficients, numbers on variables in order to make the car go round. I think you can choose from these selections of cars, and if you get it round the track, I'm not sure what you get. You win a laptop. So this is the ways where that wasn't supposed to happen. Where the car has to go through a series of timed markers, and the closer you are to a marker, the more points you get. And of course, if you get closer, the closest person who gets to the marker actually wins the prize. which is a video camera. So this is the Sun booth, the Java Sun booth, Solaris, everything Sun booth here. Let's go quickly straight through, see if we can see other people. This is Wonderland, this is a 3D environment here. Just Java DB, GNU Linux, this is Open Solaris, Open JDK. I'll see if I can find someone for an interview. Solaris Express, Ajax, Java EE, I don't know what Capsys, Sluggable, Open ESB. This is embedded silicon chips, Java cards again, credit cards and all that. I'm trying to find someone, let's keep it going. Try and find someone who knows about something really interesting. Okay, this is the pet store, sorry. Yeah, a pet store. So this is a pet store.
So this is the grouping catalog that come with the
you want them to show it to you?
So they have Ajax programming.
Yeah.
All the different.
Do you want them to show you through it?
What this is Sun and Microsoft came out with the announcement a couple years ago that we were going to cooperate and make our technologies integrate. That's really what this is. Right here is the output of that work. And so our scenario to illustrate it is kind of a hospital situation. So patients are coming in, they're going to initially talk to, say, someone from the nursing staff who's been equipped with maybe even a mobile device with Excel on it. But it's all Windows based with .NET. That's the key part of that scenario. So the nurse is going to fill out their initial information.
Right, so this will be a nurse logging into our system.
What's that?
Yeah, this will be a nurse logging into a medical surgery or a practitioner.
Exactly.
Right, social security number.
Yeah. So the point is, the nurse just gathers the initial easy contact information and such. Then this is where the web services interoperability piece of this comes in. So
this is a web service now.
Exactly. So with modern versions of Excel and other Microsoft applications on Vista, they are tied into .NET, and .NET makes them web services enabled. So with just a small amount of macro definition within the spreadsheet, we've told it, when you persist your data, persist it out by calling this web service. And I'll also show you the other direction. But so first we're going to show from Excel. Hey Penny, how you doing? I'll come back and catch you. I'm going to get it. See you. Sorry. So we're going to see that information. So it got assigned, this is a new record, got assigned ID 40. We see this over here now in Sun's technology stack. Completely different technology stack. It's open source, Project Glassfish, and the web services stack that's related to it.
So that's a simple JSP or some view,
Yeah, that's a simple view of that. And now in our little scenario, the doctor comes along. And he's going to fill in a diagnosis code for this patient. So he examines them and says, you've got 792, whatever that's a code for. Okay? So now, again, that's persisted out on the application server in its database. And the next time the nursing staff member comes along and does a sync operation in Excel, they get it.
So they get diagnosis 792.
Yeah. So the whole key here, obviously sharing information over the network isn't particularly new. What's new about this is that .NET applications are web services enabled essentially for free. And Sun and Microsoft have gone to the effort as part of our partnership to make sure that it is as simple as possible to make our separate web services stacks interoperate. And that's what Project Tango is. If you'd like to get more info on it.
So that was Project Tango. Now look what they've done with the old Wheel of Fortune. Last year it was a manual wheel that you spun. Now it's gone digital. And it's all in 3D. And if you get lucky, you get a nice big prize. But if you don't, you end up with just a mouse. Just to show you how mad this conference is, we actually now have hard-working masseurs. Very hard-working masseurs.